Hey everybody, how you doing? Hopefully everybody's doing okay. I want to sort of go over a little MP5 and I'll go over the Java version, which is basically just like the C++ version, dealing with finding least squares formula to determine the equation of a line and the best fit analysis from ordered pairs X and Y, which you'll get from your file. You'll download the mp5.imp. So basically, you have your slope and your y-intercept right there from your equation, the function of a line, which is y equal mx plus b. And basically, you'll deal with some variables that help solve the equation for you to get the best fit analysis. And basically, you're going to get your end results, as you'll soon see, in your output to a file. So let's say if I go to here, we get data that's presented to a file. So in C++ and Java, you have objects that you deal with that will be for output that you'll create. And we have them supplied for you. So you'd be okay to grab data from a file, and you'll be able to read the data from a file into some points X and Y. And Java tokenizes it, so that's what that's called right there. So a token is a character value from the stream, input stream, which will be from a file in our case, the mp5.imp. And if you look at the data, it's right down there. And so if I went to grab the data, we can get it and evaluate it, okay, which we'll do in a second. So one thing we see here, if you log into the site myfiles.oakton.edu, you can sort of get a glimpse at a spreadsheet that we have online for you that we present, which is showing a linear regression worksheet and basically a bunch of XY points that you'll see from your file, mp5.imp. You want to read them in, and it basically calculates that slope and intercept, and that forms a linear regression line off the data. So, which is sort of what you see presented in from equation form here, which you'll see on your hints. So you want to definitely look at your machine problem course hints, and basically you're going to get that linear regression equation, and you're going to sort of see what you're going to be ending up with for a solution. The one thing you also get is a correlation coefficient. It says a useful statistics, how realistic are impulses for the data model. So it sort of tells you what the best fit is in a degree. So usually about 80% to 100%, that correlation coefficient will tell you how close those points are lying that line or close to that line. Anything below 80% is getting kind of thin, down to 0%, of course. So less of the values of 80%, it's not really a tight fit. So when you examine data points, you can sort of see there's succession in the data points, as you'll sort of see when we go through the motion there of our detail that we supplied, that you'll sort of see in our display here. So I'm going to grab really quick the data points that you're going to see here. I'm going to show you a pretty easy way to get this working. And there's, you see that succession, the X column sort of and the Y column of data. And there's your sort of succession points. So what I'm going to do is I'm going to grab our starter file, which we definitely have to download. Those are data points. So we'll just grab that right there. All right, so when I look at ls to view the files, ls-l log format shows you I have some data bytes. And eventually we're going to take that data and we're going to do something with that data. Now I'm going to overwrite this mp5 file with the C file information that we give you or the Java file information we give you. So I'm just going to I can just copy the whole thing, really. Doesn't matter. Copy it. And we're going to pretty much go by the bullet points. And you can continue some of those bullet points some common points where you're going to place in, try to match it against the machine problem PDF that we have online for you, so you can sort of work the problem. It's only pretty much one part that you need to worry about. So if I open up Pico mp5.java, pretty much don't need this stuff, so I'm going to Control-K it out. I'm just going to put my own stuff in here. Again, I just do this to have a little bit cleaner way to read what the comments have by line that we have paralleled here in your area there on the heads file. So what I'm going to really do is run this guy right away, and because we get data points for X and Y, I will be able to output them just so you can see, hey, we get something here. So I would see that out if I was C++, but I'm not C++, so I'm Java. So system.out.print that, just so you can see that we read in the data, we've read it incorrectly. And here are our points. Okie doke. So I'll run that, save it, boom, bam, boom. Java see it. Should compile fine. Bam, a lamp. Oh. Okie doke. Back to the drawing board. Correct that and resave. Bam, sorry. Okay, we're good. And now I'll run this bad boy, and you're going to see, you sort of should see this to the screen. So we got our dump, we're good. Now I want to go back, and the only thing you got to really do is you want to write to the file correctly, because that update part is going to be needed, because right now you see the object fout that you'll have in C and Java that we sort of named it here. That's the file writer versus the file reader, fn. Pretty much parallels with C++ stuff. You can see that a file has been written. That's the output file, which is mp5.out, which shows our answers. There's 63 bytes as it seems. So if I cat that, CAT to read to the screen, just because I want to make sure it's right before I submit it, I'm going to hit that, and you can see I got not a number because I didn't update my variables correctly. That you have to do. So the only thing you really need to do is check your wording here correctly. Go through this. Always is good to know some of this information. And you want to sort of go to the second last page there, about page 14, and that's where you're going to have your update reduction variable. This you want to sort of do here to update values correctly, because I'm reading inside the loop every time, and things are changing in that loop, or I want things to change as I go through a loop. So in other words here, I want things to sort of change as I go inside that forever loop. Okay, notice we sort of keep going until we reach the end of the file, similar in C++, and we break out of the loop. And then after I break out of the loop, these calculations will be understood. And we have that built-in function, so when integrate is called, bam-a-lam, that will help you out right then and there with your end result. You have that calculation, that function that's inside your code, and you don't have to do anything there. But these variables obviously are going to be written to the output file, and you want them accurate. So obviously something has to change with your sum x, sum y, your count, etc., etc. So those are your variables that are here. So as you pull the data x and y, there's assignments with these particular variables that help you to calculate your equation of a line and your correlation coefficient. So if I'm going to go to that line, comment on 12 there, it says update reduction variable. So here it says, okay, update n. Well, we don't use n, we use count, so obviously that's going to be count plus plus, or count equal count plus 1. Update your x by x. So I'm going to want to sort of summate x and update that sum x by, as we think here, X.
Skype video.
Okay, it's good old Skype. Sorry about that. And that's it. Bada bing. You want to keep going here. Keep going, keep going. And what you need to go ahead and run this puppy. Okay? And when you do it, you're going to see your results fly. And I wish you the best of luck. Okay? Take it easy. See you hopefully Tuesday.